In this video, we're going to discuss rational expressions and rational functions. A rational expression is an expression in the form of p divided by q, where p and q are polynomials, and q cannot equal 0. So I've written a couple of examples of rational expressions. So a rational function is the function of the form f of x is equal to p of x divided by q of x, where q of x cannot equal 0. And I've given you examples of rational functions. Recall, if the denominator of a fraction equals 0, then the fraction is undefined. So we want to be able to write the domain of each rational expression or rational function in interval notation. All right. So our first example is a rational expression. So again, I want to figure out when it's going to be undefined. So I'm going to set the denominator equal to 0. This is factorable. Negative 4 times negative 3 is a positive 12. And when you add negative 4 plus negative 3, that's negative 7. Set each factor equal to 0. So these are the only two numbers that make the denominator 0. So I'll have an open circle of 3 and an open circle of 4. Every other value is okay. So now I want to write these three regions in interval notation. So starting from the left, that's negative infinity to 3, or 3 to 4, or 4 to infinity. Okay, let's take a look at the next example. Again, all I care about is the denominator equaling 0. I can factor out an x. And I can factor this trinomial too. All right, so set each factor that contains a variable equal to 0. X equal to 0 is done. So we have negative a half and negative 3. So let's put these values on a number line. No other values make the denominator 0, so I'll shade the rest of the number line. So here I have 4 regions. So let's start from the left. Negative infinity to negative 3, or negative 3 to negative 1/2, or negative 1/2 to 0, or 0 to infinity. Okay, one other example I want to take a look at then. So, when I take a look at the denominator, okay, initially if I set it equal to 0, that's not factorable. There's no sum of squares. Okay? But let's think about this a little bit before we do anything else. When I take a number and square it, what type of values do you get? Well, you either get 0, because 0 squared is 0, or you get a positive number. For instance, negative 3, the quantity squared is 9, and 3 squared is 9 also. So, if this is 0 or a positive, and I add 1, is the denominator ever going to be 0? No, it's not. So, I have no domain restrictions here. So in this particular case, the domain is all real numbers, but I can write it like this in interval notation. So just because I have a variable in the denominator does not necessarily mean I'm going to have domain restrictions.